Good morning, students. Welcome to the online class. So let's begin with the example number 16. So yesterday we have finished almost all examples. So this was the only one left. Okay. And yesterday we have studied problems based on occurring together. Okay. So now we have similar type of questions also. And this is also very important question. Okay. So let's read the question. What's the question here? The question here is, find the number of arrangements of the letters of the word independence in how many of these arrangements. Okay, so the first part is find the number of arrangements of the letters of the word independence. Okay, so we have to find the number of arrangements of the letters of the word independence, right? In how many of these arrangements? So in these arrangements, how many of them the words start with B? Second one, all the vowels occur together. Third one, or do the vowels never occur together? Fourth one, do the words begin with I and end in P? So this is the question, students. Okay. So now first let us see whether it is a distinct, does it have a distinct objects or it's not a distinct objects. Okay, so distinct objects means every letter or every given object must be different, right? So if you observe here, there are some letters which are appearing more than once. So that means it's not a distinct object, right? So now let us count them. So which formula to be used here? N factorial by P1 factorial, P2 factorial, P3 factorial, so on up to Pk factorial. So now let's count how many letters are there, right? So it's 3, 6, 9, 12. Okay, there are 12 letters in the word independence. Right, so there are 12 letters in the word independent and they are not distinct. If it was distinct, we would use NPR formula, n factorial by n minus r factorial, but since they are not distinct, okay, so in which we can see, okay, in which I, so how many times I is occurring here? It's only one time, right? So there is no group of I. Now n if you see, it is occurring 2, 3. So it is occurring 3 times, right? And D, if you see, just check D. So D is appearing more than once, that is 2. And D, right? So 1, 2, 3, 4. Right? So now P. So P is appearing once only. E is already taken. M is also already taken. D is also already taken. E, N, C. So C is appearing once. Is that clear? So this is how the group different letters are appearing, right? So I is appearing one time, M is appearing 3 times, D is appearing 2 times, and E is appearing 4 times. So these are so there are some objects which are similar, right? So there are some objects there are similar. So which formula to be used now to calculate the total number of letters are 12, right? So the total number of ways in which you can arrange the word independence is 12 factorial, right? So but there are some which is appearing more than once of one kind. N is of one kind, D is of one kind, E is of one kind. So it says 3 factorial into 4 factorial into 2 factorial. Is that clear? So these are the total number of ways in which independence can be arranged. So it's 12 factorial by 3 factorial, 4 factorial into 2 factorial. Yes, students. So now let me solve this one. So it's nothing but 12 into 11 into 10 into 9, 8, 7, 6, 5, 4, 3, 2 into 1 whole divided by 3 factorial, 3 into 2 into 1, right? 4 factorial, 4 into 3 into 2 into 1, yes. So this is 2 into 1, right? So just keep on simplifying. 3 2s are 6, right? So this and this 6 get cancels, right? So here 4 3 2 1 get cancels with 4 3 2 1, right? So this 2 into 1 is 2, 2 ones are 2 fours are, right? So 12 into 11 into 10 into 9 into 4 7 into 5. So the answer you will get is 1663200. Okay, so just take the use of help of calculator and simplify, because it will take time here and the time won't be sufficient for solving the problems. Okay, just take the help of calculator. So this is how the 12 letters are arranged among themselves when n is of one kind, d is of one kind, e is of one kind. So what is the answer here? It's nothing but the number of arrangements. The total number of arrangements are 1663200. Is that clear? Okay, so now let me solve questions bit by bit. Okay, I need space, so that's why I'm erasing it. So now the first part. So what is the first part they are saying? The words should start with P only. So how many letters are there in the word independence? There are 12 letters, students. Right? So there are 12 letters. So there are 12 boxes, right? So I've just put 3 dots, means it is continued. So till the last one. So 12 boxes. Is that clear, students? But the condition given here is the word should start with P only. Means the first place has to be filled. The first place has to be compulsorily filled by P only, right? So there is no change in it, right? So the first place we should fix it with P only, right? So now among the 12 letters, P we have used and it is fixed. So now we should see in how many ways the remaining 11 is arranged. Okay, because the first place is to be filled by P. So you can fill it in one way only, right? So now how many are left now? 11, right? So in that 11, so P is gone now, right? So P is already filled. So you have to fill the remaining 11 among these, right? So check if there are any letters appearing more than once. Yes, students. So N is appearing 3 times, D is appearing 2 times, and E is appearing 4 times. So 11 factorial by 4 factorial, 2 factorial, 3 factorial. Okay, we are using this formula because they are not distinct objects, right? So we have a formula n factorial by p1 factorial, p2 factorial, up to so on up to pk factorial. Okay, is that clear? So the first one condition is the word should start with p, means you have to fill the first box by p compulsorily, right? So p is filled now. So how many empty boxes are still remaining? 11. Okay, so those 11 you can arrange among themselves. Okay, you can move this to this side and then you can pick anyone this side. So that kind of arrangement among the 12 boxes, sorry, remaining 11 boxes will be 11 factorial, right? So among the given, so P is gone, right? So still there are some letters which are appearing more than once. So use not distinct objects formula, right? So 11 factorial by 4 factorial into 2 factorial into 3 factorial. So this is again simplify this one. 11 factorial means 11, 10, 9, 8, 7, 6 up to 3 to 1. 4 factorial, 4, 3, 2, 1. 2 factorial, 2 into 1. 3 factorial, 3 into 2 into 1. So upon simplification, the answer you will get is 138600, right? Is just to, okay, so upon if we keep on solving, it will take a lot of time. Okay, so just use the calculator and just check, okay, whether the answer is right or wrong. Okay, so 138600. So among the arrangements of the letters of the word independence, if first one, if the words start with P, so how many words we can form starting with P is 138600. Is that clear, students? Now let's go to the move to the second part of the question. Okay, so the second part of the question is do all the vowels occur together? So they are talking about the vowels occurring together. Yesterday only we have discussed if there are any objects which are occurring together, right? So they have to be kept under one box only. Okay, so that they will always remain in one place itself. Okay, they should be together, right? So here we are used P, right? So it was 1. Okay. So do all the vowels occur together? So among these, the given letters, which are vowels, right? So among the given letters, so vowels are A, E, I, O, U, right? So among those, I is one vowel and E is one vowel, right? So there are 4 E's and one I. Is that clear? Okay, so you have to group them since they have to be together for time being. So tie them up and put them in one box, right? Right. So now they are together, right? So these objects are together, always together. So this won't change, right? So these objects are always together. So there are total 12 letters, right, students? There are total 12 letters, right? So already in this box, 5 are gone. So among 12, so for time being, so this is our one object, right? Because these letters have to be together, the vowel should be together, right? So among the 12 letters, so how many are left now? We are left with 7 objects. Right, students? So 12. So in that 12 letters, 5 we have already used here, right? 1, 2, 3, 4, 5. So if you subtract 5 out of 12, so how many objects are remaining? 7 objects, right? So these 7 objects along with one object which we have put all the vowels together accounts for how many objects? 8 objects. Right, students? Right. So 8 objects means 8 factorial arrangements. Right. So E has gone now. E has gone into the box. Right. So forget about this. E and I have gone into the box. Right. So 8 objects have to be arranged among themselves. So these boxes will be arranged among themselves. So these are nothing but 8 factorial, right? So in these 8 factorial, are there among the remaining letters, are there any letters of one kind which is appearing more than once? N and D. So this is nothing but 3 factorial into 2 factorial. Right, students? Okay, so and along with this, still the event is not complete. The event is, so in this first object, right? So vowels are together, so they are sitting together, right? So they are sitting together intact. So they can arrange, they can shift their places, they can arrange themselves, right? So how many objects are here? 5 objects means 5 factorial. Okay, so 5 factorial. But since E appears 4 times, so it's nothing but of one kind, 5 factorial by 4 factorial, right? So the total number of ways in which you can arrange the vowels together is 5 factorial by 4 factorial into 8 factorial by 3 factorial into 2 factorial. Okay, so is that clear, students? So this will be the answer of the second one. All the vowels occur together. Okay, so now just keep on simplifying. So 5 factorial means 5 into 4 into 3 into 1 divided by 4 into 3 into 2 into 1. So similarly simplify and the answer you will get is 16800. A lot of time will be going into simplification, and we have done simplification already, how a factorial is simplified. So just take the help of definition of factorial and calculator, you will get the answer. So 16800, right students? So now the third one, so let me write here. So do the all vowels occur together. 16800 is the number of arrangements of the words having vowels occur together. Right. So now do the vowels never occur together. Second one was occur together. Okay. And the third one is they should never occur together. They should never sit together. Okay, so such type we have solved in the last class itself. So it's nothing but among the total arrangements of the letters of the word independence, okay, remove with the restriction. So in the total remove, vowels occur together, right? So these second part is regarding vowels occurring together, right? But now we need vowels do not occur together. So among the total arrangements, remove the words or the arrangements which are occurring together. So what will be left? What will be the left? Never occur together, right? So the same way. Right, so yesterday also we have discussed. So if they have given you some 10 numbers, right? So how many total numbers are here? You are having 10, right? So among them, so the restriction is to pick even and odd numbers, right? So if you remove even numbers, what will be left? Naturally odd numbers, right? So this also. So among the arrangements of the words of the independence, okay, so the first restriction was they should occur together, right? So in the total, if you remove the vowels occurring together, you will get vowels never occur together, right? So the third one, number of arrangements where vowels never occur together, vowels never occur together. Simplification is very easy. Just write down, just understand how the solving is done. Number of arrangements of vowels never occur together. So this is what we need to solve. Never occur together is equal to total number of arrangements minus vowels. Number of arrangements, vowels occur together. Right, students? So what is the total? So that's what I have written it because I had erased it. So 1663200, right? Vowels occurring together. What's the answer? 16800. So now just subtract, students. What will be the answer? The answer will be 1646400. Right, students? Okay, so just understand simplification, you can solve it on yourself, don't worry. Okay, just understand how the problem is being solved. Okay, number of arrangements of vowels never occur together is 1646400. Okay, so now the last condition. So the last fourth condition is do the words begin with I and end in P. Okay, so it's beginning with I and ending in P. So what we have erased here, I, 1, so E was appearing 4 times. So the fourth one, right? Do the words begin with I and end in P? So how many letters are there in the independence? 1, 2, 12 letters, right? So 5, 3, 6, so on up to. So let me assume this is our last 12th box. Okay, so there are boxes between. So now, so there are 12 letters. So there are 12 letters in the word independence, in which I is appearing one time, N is appearing three times, D is appearing twice, E is appearing four times, P and C are also appearing once. The condition in the fourth question is the arrangement of word must start with I. That means my first place is already filled I, right? So it starts with I and end in P, means P is also fixed here, right, students? So this is our first place and this is our last place. Okay, so 12th. So the first, so how many such arrangements you can make where the word is starting with I and ending with P only. So this is fixed, right? So we don't know how the arrangements are done in the remaining 10. Yes, students, because there are 12 letters, right? So in those 12 letters or the 12 boxes, first one is fixed, right? And the second one is also fixed. So how many are left? How many boxes are left? 10 boxes are left now. And these 10 boxes, right? So these 10 boxes can be arranged among themselves, right? So if there are distinct objects, it will be 10 factorial only. But do see, so I is gone here, right? So P is in the last place. Okay, so among the remaining, are there any occurring more than once? N, D, and E. So it's 3 factorial, 2 factorial, and 4 factorial. Okay, so the number of arrangements of the words which start with I and end with P are 10 factorial by 3 factorial into 2 factorial into 4 factorial. And just simplify, students, the answer will be 12, 6, double zero. Okay, so is that clear? So this is regarding the example 16. Okay, students, so now we shall see exercise 7.3. So exercise 7.3, first question is written on the board. Okay, and the question is, question number 2, how many 4-digit numbers are there? So how many 4-digit numbers are there with no digit repeated? So we have to form a 4-digit numbers. We have to form a 4-digit numbers, and the condition given here is, no digit is repeated. It's that clear, students? Okay, so now the solution of the question number 2 from the exercise 7.3. The first one we already solved yesterday. And if you look at the question number 2, you may ask that, sir, you have told us to find or make a 4-digit numbers, but you haven't given us, so which numbers do we need to use, right? So how many 4-digit numbers? You can see the third one, right? There is a difference between question number 2 and third. How many 3-digit even numbers can be made using the digits? So these digits only must be used and solved. The question number 3. But which digits to use in this case, right? So in that case, when they don't give which digits we have to use, so take all the numerals, right? So what are those? So we have, so solution of question number 2, we have 10 digits, right? So out of 10 digits only, all the numbers are made, right? So how 11 is made? It's taking 1 and 1. How 100 is made? It's taking 1 and 0 and 0. So what are the digits we take? So it's from 0 to 9, right? So using 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So using these digits only, we can make any digit number, 2-digit number, 3-digit number, 4-digit number, 5-digit number, right? So when they don't give, Using which digits we need to solve? So just take the general digits 0 to 9. So 4-digit numbers means, so let me draw 4 boxes. So 4-digit numbers means it is a 1,000-letter word. So this is our units place, tens place, hundreds place, thousands place. Right? So whenever 0 is there, always be careful, students. Why? Because the we need to form a 4-digit number. Right? So this makes sense. So this will be read as 2002, right? So this will be read as 2200, right? So these are all 4-digit numbers. So what if I place 0 in the first box itself, right? Okay, it's look like there are 4 digits, but how do we read this? This is nothing but 378, right? So just a 3-digit number, right? So we are not solving here a 3-digit number question. We are solving a 4-digit number. That means 0 must not be placed in the first place or the thousands place, right? Okay, students. So thousands place 0 cannot be filled. So that is out of the possibilities of taking. Okay. So now what we need to do? 0 cannot be taken. So how many are left now? From 1 to 9 we can take. So thousands place can be filled in how many ways? How many possibilities are there? 9 ways. And I have to fill the hundreds place also. So that's why multiplication rule. So hundreds place. So in hundreds place we can fill 0. It doesn't matter, right? So but only in thousands place you cannot fill a 0. So hundreds place, for hundreds place now 0 also can be filled. So from 1 to 9 only you have to fill the thousands place. So right. So from 1 to 9 only you have to fill the thousands place. So in that if 1 has gone, so how many are left now? Here 8, right? Okay, 8 objects are there. But for the hundreds place I can take 0 also. So how many ways we can fill the hundreds place? 9 ways. So now among this, if I have used one more for this, right? So how many are left now? 8. Right, students? So similarly, units place, if I take this one, okay, if I fill it this one, so now 9. So what's the answer? 9 into 8 into 7. Is that clear, students? So 9 nines are 81, right? 7 eights are 56. So just calculate and see what will be the answer. The answer will be 4536. Okay, the multiplications and all those things you can solve very easily. Okay, so let me not go into that. Okay, now the third one, right? So what is the third question? How many 3-digit even numbers? So there is a 3-digit, right? So there is a 3-digit, but with the condition it has to be a even number only. Can be made using the digits 1, 2, 3, 4, 6, 7. 5 is not given in the question, I guess. Yeah. So the question number 3, how many 3-digit even numbers can be made using the digits 1, 2, 3, 4, 6, 7? With the condition, one more condition, no digit has to be repeated. Okay. So the third one. So what are the, we need to solve a 3-digit number with one condition, even numbers. It has to be a 3-digit even number only, means among these using. Okay, so a digit is even. When is it even? When the unit place occupies only even numbers. Okay, so what are the digits given? 1, 2, 3, 4, 6, 7. Okay, so let me draw a 3-digit number. Right, so this is a units place. tens place and hundreds place, right? So if a number is even means the units place must be filled by even numbers only. Okay, students. So what are the even numbers in the given question? The even numbers are 2 or 4 or 6. So how many options do we have to fill this one? So the units place can be filled in three ways and no digit is repeated, right? So let me assume that so either 2 is into this or 4 is into this or 6 is into this. Okay, so now how many we are left with? So we are left with 4 and this one 5. So the tens place can be filled in 5 ways. Is that clear? So no digit is repeated. Any one number is filled here, right? So now that number cannot be used again for the hundreds place, right? So let me just guess that 3 is filled. So how many are left now? 4 ways. Hence by multiplication principle, the total number of digits, 3-digit even numbers we can make is 60. Right, students? Okay. So wherever necessary, wherever it is simple, just use the box method or the fundamental principle of counting, or even it is multiplication principle or additional principle. Okay. So in some cases we need to use the formulas. They will take NPR only. It will be easier. Okay. Now the next question. So the question number 4 is, okay, so the question number 4. Now we have completed the problems which were on the board. Now question number 4. So question number 4, solve it as homework, students, because it is quite similar to the problems which we have been solving till now. Okay, and one more thing, if you solve all the worked examples thoroughly, those are enough to understand and solve the exercise 7.3 problems. Okay, so first understand the worked examples properly, and then the exercise problems will be very easily solved by yourself itself. So question number 4, take down the question, students. Okay, find the number of four digit, four digit numbers, four digit numbers that can be formed, that can be formed using the digits, that can be formed using the digits 1, 2, 3, 4, 5. If no digit is repeated, if no digit is repeated, right? So you can use the fundamental principle of counting or even the NPR formula, right? Because all the digits given are distinct. If there are distinct objects, NPR formula. If they are not distinct objects, n factorial by p1 factorial, p2 factorial, so on up to pk factorial, right? Full stop. how many of these how many of these will be even? So how many of these will be even? So here the question itself comprises of two questions. Okay, students. So find the number of, you have to find a 4-digit number. You have to make a 4-digit number using the digits 1, 2, 3, 4, 5. Is that clear? And all are distinct, right? So form a 4-digit number out of these. So 5, right? So they have given you 5 digits. You have to make a 4-digit number, right? Is that clear? And because no digit is repeated. And how many among these, how many we are even numbers? Means you have to form a 4-digit number also. You have to form a 4-digit even number also. Is that clear? So solve this as homework. Take down the question, students. Okay, so now fifth one. So the fifth question is, from a committee of 8 persons, fifth one, from a committee of 8 persons, in how many ways, in how many ways can we choose, can we choose a, in how many ways can we choose a chairman and a, choose a chairman and a vice chairman, chairman and a vice chairman, assuming one person, assuming one person cannot hold more than, cannot hold more than one position. Okay, so just analyze the question. Till then I'll rub this side. Okay, read the question. Always don't be in a hurry to solve the problem, okay, in mathematics. So just take some time, read the question, okay, then you will understand it what they are asking. So there is a committee of 8 person students, right? So there is one committee, so in that committee there are 8 persons, right? So in how many ways can we choose a chairman and a vice chairman? So there are two positions, right? So chairman and a vice chairman, there are two positions, right? And there are 8 different persons. So can we choose in how many ways can we choose a chairman and a vice chairman, assuming that one person cannot hold, this is important, this assumption is important, or the condition, assuming that one person cannot hold more than one position. Is that clear? So there is a group, there is a committee, there are 8 persons, right? So let me name them as P1, P2, P3, P4, P5, P6, P7, and P8, right? So there are 8 persons, right? So among the 8 persons, you have to pick a chairman and a vice chairman also, right? You have to choose a chairman and a vice chairman also. Is that clear? Assuming that a single person cannot hold more than one position, right? So let me first write down the chairman. So among eight, so to pick chairman, so how many persons are there? 8 persons. So among 8 persons, how many you can fix here or choose for the chairman? There are 8 ways. All the eight persons are available for the post of chairman, right? So among this, let me assume that P4 person has been given chairman post. Now I cannot give P4 the post of vice chairman also, because a single person cannot hold more than one position, right students? So how many persons are left now? 7, right? So now the event is over. So what was the question? There is a committee of 8 persons. So among the 8 persons, you have to choose a chairman and a vice chairman, okay, with the condition one single person cannot hold more than one position, right? That means not repetition. So this is 8 into 7 ways, so it's 56 ways. So there are 56 ways in which we can pick a vice chairman and a chairman. Okay, so now sixth question, students. So what is the sixth question here? The sixth question is, find the value of n. And such type of problems also we have solved in the last class. and I believe you have been practicing it daily. Okay, be in touch with the mathematics subject. Okay, don't sit for studying mathematics once in a while. So daily it is required. Okay, so question number 6. Question number 6 is find n if n minus 1 p3 is to np4 equal to 1 is to 9. Okay, so find n if this is the condition given. Okay, so now let me solve. N minus 1 p3 is to np4 is equal to 1 is to 9. So this is nothing but ratio n minus 1 p3 whole divided by np4, which is equal to 1 by 9. Yes, students, so n minus 1 p3, so using npr formula, so in place of n we have n minus 1, so n minus 1 factorial whole divided by n minus r, n minus 1 minus 3, n minus 1 minus 3 factorial whole divided by np4, n factorial by n minus 4 factorial, which is equal to 1 by 9, students. So let me keep on simplifying. So I'll get n minus 1 factorial whole divided by n minus minus 1 minus 3 is minus 4, n minus 4 factorial, right? N factorial divided by n minus 4 factorial, which is equal to 1 by 9. Yes, students. Okay. So you can write this as, so if you see, this is nothing but of the type a by b whole divided by c by d, right? So I can write this as n minus 1 factorial divided by n minus 4 factorial into n minus 4 factorial whole divided by n factorial, which is equal to 1 by 9. So now if you observe, n minus 4 factorial, n minus 4 factorial get cancels. Okay, students. So what we are left now? So what do we have now? The remaining terms are n minus 1 factorial whole divided by n factorial, which is equal to 1 by 9, students. Okay, so now keep on observing carefully at each and every step. Okay, n minus 1 factorial. So can I write n factorial as n into n minus 1 factorial? I'll stop here itself. So n factorial definition, n into n minus 1, n minus 2, so on up to 3 to 1. But since I have n minus 1 factorial in the numerator, so I'll keep it as it is because our simplification will be much easier. So this get cancels, right? 1 by n is equal to 1 by 9. Just cross multiply, students. Right? So what is the value of n? The value of n is 9. Okay. Now let me look at the 7th question. Seventh question. Find R if first one 5PR is equal to 2 into 6P R minus 1, and among the 7th only we have 2 bits. Second one 5PR is equal to 6P R minus 1. So find the value of R if 5PR is equal to 2 times the 6PR minus 1. Now just apply the formula. So the first one, let us solve the first one. 5PR is equal to 2 into 6PR minus 1. Right, students? So 5PR can be written as 5 factorial by 5 minus R factorial. Right? 2. So 6PR minus 1 can be written as 6 factorial by. So what's the formula of NPR? n factorial by n minus r. So what is n here? 6 minus what is r here? In place of r we have r minus 1, right? So now let's keep on simplifying. 5 factorial by, and keep observing at each and every term, students, okay, so that we can reduce our simplification. So now can I write 6 factorial as, so what is 6 factorial? 6 into 5 into 4 into 3 into 2 into 1. So this can I write it as 6 into 5 factorial? Okay, so 6 factorial is nothing but 6 into 5 factorial, right? So divided by 6 minus r, so plus 1 factorial, and 5 factorial and 5 factorial get cancels. So 1 by 5 minus r factorial. So 2 into 6 is 12, right? Because this is twice the 6p r minus 1, right? So 12, 5 factorial is cancelled. So 6 plus 1, 7. 7 minus r whole factorial. Okay, students. So now we are reduced to this term. Okay, so now look at each and every term so that we will make a common term and cancel the rest one. Okay. So 1 divided by 5 minus r whole factorial is equal to 12 divided by. So can I write 7 minus r factorial as 7 minus r? Okay. So when you open the factorial notation, it keeps on getting reduced by 1, right? So 7 minus r minus 1 will give us 6 minus r, right? So still it won't help us. So now next, 5 minus r, stop here itself because we have a 5 minus r factorial on the other side also. Okay, so 5 minus r factorial, 5 minus r factorial get cancels. Okay, so now just cross multiply. 7 minus r into 6 minus r equal to 12, students. Now just simplify this one. 7 6 are 42. 7 minus r minus 7 r minus 6 r, keep on multiplying. Okay, so 7 into 6, 7 into minus r into 6 minus 6 r plus r square is equal to 12, right? So 42, right? So what will be this? Minus 13r plus r square. Take 12 to the left hand side, right? So now we got a quadratic equation. R square minus 13r and 42 minus 12 will be plus 30 equal to 0. Now just we have a quadratic equation. So by factorization method, we can solve it. Right. So r square. So how will you factorize 30? So that when you multiply, you should get 30, right? So this r square coefficient is 1. So 1 into 30, 30. So the two factors will be minus 10, minus 3. Because upon adding also, I should get the coefficient of r, minus 30. So minus 10r, minus 3r, plus 30 equal to 0. So here r is common, right? So and here you can see minus 3 is common, right? So now r minus 10 is common, r minus 3 equal to 0. So which implies r equal to 10 or r equal to 3. Yes, students. And what was the question? The question was 5pr is equal to twice 6pr minus 1. Yes, students. Okay. So now see which r gives us some meaning or understanding, basic understanding of the permutation. Okay. So if you take r to be 10, right? So out of 5 objects, how can you arrange 10 objects, right? So this is totally meaningless. So the answer has to be 3. So now easily you can understand, right? So out of 5 objects, you can arrange 3 objects, right? Okay, so this was the solution of the 7th question, first bit. The answer is r equal to 3. And if you see, the second bit is also very similar and easy. So solve this one as homework. Okay, students. So two problems have been given homework, and they are quite similar to the problems which we have solved. Okay. So now, okay, so whatever problems we have discussed till now only will be asked for the exams. So don't worry, we haven't finished. Still, there are four problems, right? So don't worry about those. So for the exam on Sunday, so only these questions will be asked. Okay, thank you. Okay, so the doubt is regarding example 12 and the second bit question. So what is example 12? Find the value of n. Find the value of n such that second bit. Student is asking regarding second bit np4 whole divided by n minus 1 p4 is equal to 5 by 3 with the condition that n is greater than 4. So the question is find the value of n if np4 by n minus 1 p4 is equal to 5 by 3. So let's start the simplification. np4 by n minus 1 p4 is equal to 5 by 3. Okay, so just cross multiply the things. 3 times np4 is equal to 5 times n minus 1 p4. Okay, so now apply the formula. So what is the formula? 3 into np4 is n factorial by n minus 4 factorial. Yes, students. So which is equal to 5 into. So in place of n we have n minus 1. So n minus 1 factorial whole divided by n minus r. So what is r here? Minus 4. Okay. So 3 into n factorial divided by n minus 4 factorial, which is equal to 5. Right. So 5 into n minus 1 factorial. So now this can be written as n minus 5 factorial. Okay. So now if you observe, so can I write n factorial as n into n minus 1 factorial, right? So whole divided by n minus 4 factorial, which is equal to 5 into n minus 1 factorial divided by n minus 5 factorial. Okay, so this term and this term gets cancelled. Okay. So what are the remaining terms here? 3n by n minus 4 factorial, which is equal to 5 upon n minus 5 factorial. So just cross multiply 3n n minus 5 factorial, which is equal to 5 times of n minus 4 factorial. 3n. So n minus 5 factorial, can I write this as n minus 5 into n minus 4 factorial, which is equal to 5 times of n minus 4 factorial, right? So this term and this term get cancelled. So what are we left with? Right. So 3n n minus 5. Okay. Was np4 by n minus 1 p4, which is equal to 5 by 3. Okay, so 3 np4 into 5 n minus 1 p4. Okay, so n factorial by n minus 4 factorial. So n minus 1 factorial by minus 1 minus 4 n minus 5 factorial, right? So n minus 1 factorial n minus factorial get cancels. Yes, students. So now next 3n n minus 5 factorial cross multiply. So it is 9 n minus 4. So which is equal to 5, right?
n minus 4 next.
So 3n square minus okay, so till here. So 3n n minus 5 factorial, which is equal to 5 into n minus 4 factorial, students, right? So 3n. So what I have done here, so when n minus 5 factorial, so 5 factorial is nothing but 5, 4, 3, 2 into 1, right? So 5 is getting reduced by 1. So you can observe here. So the mistake what I have done was, right? So n minus 5, when you open the factorial, so reducing by 1 means minus 1. So it will be minus 6. So that's why I have written -4. So that was wrong over there. Okay. So is that clear now? So n minus 5 factorial is equal to 5 times. I will apply the definition of factorial here. So n minus 4, right? So now the next term will be 1 less than, okay, 1 less than the previous, right? Factorial. So 3n, n minus 5 factorial equal to 5 times n minus 4. So n minus 5 factorial. Hope so. You understood now. Got the point. So n minus 5 factorial, n minus 5 factorial get cancelled, students. So 3n is equal to 5 times of n minus 4. So 3n, 5n minus 20. Multiply 5 into the bracket. So 3n, so take the like terms together, minus 5n minus 20, right? So this is 3n minus 5n minus 2n minus 20. So minus 2 and minus 20 get cancelled, so you will get it as n equal to 10. Okay, just be careful in applying factorial notation, students. Okay. So when you open the factorial, so it keeps on reducing by 1. Okay.